What we're going to talk about in this lesson, we're going to start and we're going to talk about parametric statistics or parametric tests. And what we've done thus far this year, everything we've done has been parametric except for when we did Chebyshev's. And this is what parametric is. In a parametric test, your population has to be approximately normal. And when we did our parametric tests, we did our test for means. Everything we've done has been a t-test, a one sample t-test or a two sample t-test, something for means. What we're going to talk about today is non-parametric tests. And in high school, you likely did not do non-parametric tests. And this is what a non-parametric test does. In this, your population does not have to be approximately normal. And probably the reason you didn't do these in high school was because you didn't have Minitab. And the calculator won't do these. You have to do this on Minitab. And these are tests for medians. All right, and the first one we're going to talk about is called the sign test. The sign test can be used to test a hypothesis about the median of a population. And like I said, it's a median. The reason it's a median is because a median is not affected by outliers. And these tests work, if you did a box plot and you had an outlier, you would do this test. The corresponding parametric test is the t-test for a population mean. When samples are small, the t-test requires that the population be approximately normal. Now here's the advantage of this test. This test is valid for any population. It does not have to be normal. And the primary disadvantage is that you have a higher chance of making an error. And this would be a type 2 error. You got a higher chance. So that would be the disadvantage. And this is the Greek letter for median. I don't usually write this letter because I can't write it very good, but it's the Greek letter eta. And it looks like this. It looks like a script N. I'll show you on Minitab what it looks like, and it will look better than what I drew. What your text does, we don't have this on Alex, but what your text does is your text just calls it an M, and that's what I call it. And I'm going to tell you, just like Chebyshev's is not as good as empirical rule, these non-parametric tests are not as good as parametric. My first goal is to do parametric. My backup plan is to do non-parametric if it fails the normal condition. All right, and let's look at this first problem. You know how I talked about finding annual income in Wicomico County? Say I wanted to do this, and it says annual income in thousands of dollars was recorded for a random sample of 15 families in a certain town. The results were as follows. An economist is interested in determining whether the median, okay, so I know that this is non-parametric because I'm doing median, income in town is greater than $40,000. Perform a test at the alpha equals 0.05 level of significance. All right, so here's what I'm going to do. In non-parametric, the nice thing is you don't have to check your conditions. The conditions have already failed. Okay, so let's go back to this problem. My goal with this would have started out determine if the mean income in town is greater than $40,000. I would want to do parametric. I would graph this, and you all see this outlier. That's definitely an outlier, so I couldn't do it. Where I can't do it, I changed to non-parametric. I'm going to do the median, so I don't have to check conditions. Here's my HO and my H1. We want to know if the median is greater than 40. So HO is going to be M is 40. All right, and I'm going to go to Minitab. And here's what we're going to do on Minitab. A little bit of review of what we did on Minitab. if you go to graph, that was where all of our graphs were that we did on the day in the computer lab. The box plot, the scatter plot, everything we've done. If you go to stats, most of what we do is under basic statistics. Like display descriptive, that's one variable stats. If you look, there's all the tests that we've done, the one sample Z, the one sample T, two sample T, etc. What I'm going to do here, I want you to go back to stat again. I want you to go to non-parametrics. And this is a sign test. And it's going to be this very first one, a one sample sign. So I'm going to click this. Go to, and that's what we're going to do. But before we do that, let's go to Minitab and type in our data. So go to column 1 and label this. I'm going to label this as income. Once you've paused the video and type in your data, I had to stop the video, type in the data because it's a little glitchy on the iPad. But once you've typed it in, so I've typed in my data, I've called it income. I'm going to go to stat and I'm going to go to non-parametrics and I'm going to do a one sample sign. And my variables is going to be hit select if nothing shows up. And there it is. I'm going to do the income. We're not doing a confidence interval, so don't worry about the level. My test median is going to be 40. And my alternative is going to be greater than. And hit OK. And this will do the test for you. And when you look at it, what we really need is that p-value. So here's what I'm going to write as my screenshot. I'm going to write that we did a sign test for median. And my p-value is 0.212, and that's all you need. And once you get that, I'm going to give a conclusion just like what we did before. If the p-value is low, HO is going to go. Our HO is not going to go. So here's what I'm going to do for my conclusion. I'm going to say since our p-value of 0.212 is greater than alpha equals 0.05, we will fail to reject HO. We do not have enough evidence to conclude H1. And look back up in the story that the true median income in town is greater than $40,000 to conclude that the true median income is greater than 40,000. And when I interpret, I'm going to say if HO is true, there is a 0.212 chance of a test statistic as extreme or more extreme than ours. And I'm going to look at the second one, the same thing. I'm going to stop the video and type it into Minitab because of how it is on the iPad. But here's what I'm doing. It says, the length and time in minutes needed to perform a certain type of surgery was recorded for 32 operations. The results are as follows. A hospital administrator is interested to determine whether the median time for surgery is less than 170 minutes. Perform a test at the 0.01 level of significance. All right, so here's what I'm going to do. If I had 32 operations, I would do a t-test. CLT, I would do a t-test. This is telling us to do median, so I'm going to do what it tells me. Don't have to check conditions. My H1 is the median time is less than 170. My HO is the median is 170. Pause your video and go to that second column and type in time and type in this data. You don't have to erase your first column. Once you've got your data typed in, I'm going to go to stat. I'm going to go to non-parametrics, one sample sign. You don't want income. All right, so I'm going to go to my time. And I'm going to select that. My test median is not 40. It is 170. And my alternate is less than. And hit OK. And again, it's sign test for median. What I need is that p-value. All right, so I'm going to go back over here. And notice that my p-value was 0.004. My output, here's my screenshot. It's going to be a sign test for median. And my p-value is 0.004. Very low p-value. HO is going to go. And then I'm going to do the same thing. I'm going to give my conclusion. Since our p-value of 0.004 is less than alpha equals 0.01. Add another 0 on that if you're not sure which is less. Then you can tell 4 10,000ths is less than 10 10,000ths. So since it's less, we will reject HO. We have enough evidence to conclude H1 in context and that the true median time is less than 170 minutes. That the true median time is less than 170 minutes. And lastly, if HO is true, there is a 0.004 chance of a test statistic as extreme or more extreme than ours.